There you go, ladies and gentlemen.
Could you
This book is interesting in that all of chapter 1 is all equations. It's equations with no real connection to graphing.
Yeah.
So it's kind of a sort of an old school approach to solving equations. Where today we really like to really integrate the graphing and the solving. So I think it's after this section that I start doing that. So I decided, I was like, okay, I'm just going to graph just so that we can have some fun graphing, which is fun. I enjoy graphing. Okay, and you will too because I'm teaching it. So today we are looking at radical equations. Radical equations that are totally radical. And then on Monday, there's some very interesting equations that are very much pre-cal equations. So these ones are more example 1. Solve each radical equation and check. Definitely a good idea to check. So if it comes out the calculator, you want to get that out.
I do what it said.
I don't even know.
Okay. So somebody has my calculator. So I'm only one calculator today. Here we go. The square root of 5x minus 4 equals 6. I just want to refresh your memory really fast. The square root of x can be written in another form as well. X to the 1/2. Very good. Oh, you remember that? Okay.
Yeah.
Fractional, rational, okay. I'm just going to point that out. I want to keep it at the top of your head because we're going to see that sometime. Or Monday. Okay. So I cannot solve for x right now because he's trapped inside this big square root house.
So would you square root?
Square both sides. Very good. So my question to you is, why do we square both sides? So it does cancel out the square root, and I want to go as to the why of that. Because right now it's underneath a square root, right? So I could write this. I could write this as 5x minus 4 to the power of 1/2. Could I not? And then, and then if I say, hey, I want to get rid of this power of 1/2, then I can raise it to a power of 2, or also known as squaring both sides. And what do you do when you have a power raised to a power? You multiply, and what's 2 times 1/2? 1. Yeah, so what happens is when we square both sides, the square and the square root, these are inverses of one another, just like 2 and 1/2 are inverses of one another. So they cancel out each other, reduce to 1, essentially. Well, 5x minus 4 to the power of 1 is 5x minus 4, right? Equals 6 squared, which is 36. And then you can do what? Add 4.
Somebody open it.
And then
Go to the other door.
Just open it.
Other door.
You're not even don't even open it. They just want in, guys. Let them in.
Oh my God! Just open the door.
Just do it.
Oh my God!
Did you just walk out to the other door?
Yeah.
Just open it so you don't have to marker.
It's an elder.
Alright. So x equals 8. Okay, very good. Alright, if you have a graphing calculator, you can check and solve every equation using your graphing calculator, always. By putting the left-hand side in y1 and the right-hand side in y2. So if you have your graphing calculator, you're going to go to y equals. If you have a Casio, you're going to go to the graphing menu. Okay, so you're in the y equals menu. Yeah? And we're going to type in the square root of x minus 4. There should be a square root button that's a second function. On my Casio, I need to make sure I put parentheses so it knows that everything is underneath the radical. So the whole 5x minus 4 is inside the radical. The x is what under the alpha key, right here, x, theta, and t. That's the x. All right, and then I'm going to enter, and then I want to put in 6. Whoops, sorry. Oh, no, so you just did that. Okay. Okay. What? So you're not on the standard window. So did you see B window? B window. Yeah. So and then S standard. First enter.
Because y equals 6, right?
It is. Okay. All right. So when you have a graph, raise your hand if you see a picture like this. Yeah? Okay. Where is the solution? Where they intersect. So if you were to ever check your equations, which you can always do this way, it's a great method. This is the square root swoop. They always look like that. This is the line y equals 6. Where they intersect is the solution. Well, on the Casio, it's super easy. On the TI, it's a little bit harder. We can calculate the intersection. So on the TI, there's right up here is the calculate menu. Do second calc. On the Casio, G solve, graphing solve. So we're going to do second graphing solve. And the TI, do you see the word intersect? Okay, you're going to select intersect. On the Casio, do you see intersect? ISCT, intersect. All right, you're going to press intersect. On the Casio, it just does it. The intersection is at 8, 6. 8, 6. On the TI, on the TI, I'm going to show. Can I model with yours?
Yeah.
Yep.
I was gonna say
You could do trace. Yes.
And then you type in.
Yes, you could do it that way too. But I want to show you the intersect feature. So I'm going to do zoom 6 so we have a regular window. So on the TI, do second calculate the intersection. You need to move Tinkerbell with the left and right arrow keys. Move Tinkerbell to that point of intersection with the left and right arrow keys. And then you hit enter, enter, enter. Enter, enter, enter. And it tells you, if you do it right, you see the word intersection. Okay, and you see the intersection was 8, 6. Well, what's the solution? 8, the x value that we were solving for. Okay, always. Okay, The intersect feature is a great feature on your calculator. Okay? Did anyone not get it? You didn't what?
I didn't even do it. Why equal? Dude, your calculator really spent. I need to turn on that phone. That's a waste of time.
Wait, I did this wrong apparently.
Oh, interesting. Because if you did the second one, do they intersect? Oh, that's very interesting. So, okay, let's do the second one. Let's do some algebra. Okay? Yeah. No, you're not. You're right. It doesn't say
Oh, I know how to do
Dude, it's so calculated.
Oh, God.
I actually saw that.
Alright, so how do I solve for x? Ladies and gentlemen, what should I do? It's already under square roots. Square both sides. Oh, I know. So then we have 7x plus 2 equals.
Wait, I don't know. Wait, how does this work? No, it's just 9.
Oh, wow. It must be Friday, right? Yeah? Okay. Why? So the question was, did you use parentheses?
No, but I made it a negative.
No. Did you? Ladies and gentlemen, oh my goodness. -3 squared means what?
Negative 9.
No. What's being repeated?
The 3.
Just the 3. -3 quantity squared means what? -3 times -3, which is positive 9. Oh, Nelly. Do parentheses matter?
Yes.
Oh, yes.
Just like commas.
Okay, yes, commas are important.
Commas
Okay.
flags.
Okay, so then we're gonna subtract 2, so we get 7x equals 7, and then x equals 1. Here's why you must always check. Will you please plug this in? Okay. Okay, so please, in your calculators, I need you to plug in y1 and y2. The left side in y1 and the right side in y2.
It doesn't intersect.
Oh no, that's
You guys, if you don't have graphing calculators, you need to go down to the finance office and check them
I
out.
have one instead. Yeah, but
Oh,
I
okay. What?
Does this technically work?
Oh, okay.
Because
Cool.
because that means X.
How did it? Why is it up there? What did you type in?
Yeah, it's like the Friday.
Oh, yeah.
It
does
No.
The original does
-3. Oh, yeah. All right. So I'm typing in the square root of 7x plus 2. Yeah.
A square root of that. So there's
No. So the square root was already here.
if you do everything in the square root first, it'd be square root of that, right?
Oh, is it plus 2?
Therefore,
Um,
plus or minus.
No. What's the square root of 25?
For negative.
No.
Wait, plus or minus 1?
No. If I ask you the question x squared equals 25, what are the solutions for x?
Square root.
Okay. When you take a square root of both sides, that is when we must apply a plus or minus. Okay? When you do it. Okay? When the square root exists, it was there. Given to us like that. Okay? That is what is known as the principal square root. So when I give you a problem that is like simplify 36, the square root of 36, that is simplify the square root of 36. What is the square root of 36? Just 6. If I wanted the negative result, I would have said, hey, what's the negative square root of 36? And that answer would be negative 6. Okay?
Chapter 0 point something.
The difference is this is just simplify. Okay? This is solve. Yeah?
Did you guys get your?
I did. Yeah.
Okay, just thinking of someone else.
No, he's good. I got him. Thank you. Okay, so this is solving for x. How many numbers can we square to get 25? 2. 5 and negative 5. We can square to get positive 20. There's 2 answers there. There are not 2 answers here. Okay, so the difference is notation. Okay, so this is a square root that was given to us. Can the square root of a number ever be a negative result? Mm-mm. Then it'd be imaginary. Yeah. So, okay. So when we look at the graph here, there's the graph. We've got the square root swoop and a horizontal line. Do they intersect? No solution. All right, so what happens here? That is what we call a false solution. All right? So if you don't have a graphing calculator, can you figure out if your answer works? Yeah, sure you can. You can always. No, you could.
Math and it don't work.
Plug it in. So plugging it in, 7 times 1 plus 2 is supposed to equal negative 3. 7 times 1 is 7, plus 2 is 9. So radical 9. Does radical 9 equal negative 3? No, the square root of 9 is 3. 3 does not equal negative 3. This is no solution. Okay?
Do you want the no solution?
No solution, false solution, same thing. Your book gives set notation, it does that. This symbol is empty set. Empty set. There are no solutions in the set. It's empty. Okay? Alright. Now, if the square root of x is x to the 1/2, then what's the cube root?
1/3.
Oh, yeah. So this is 7x plus 6 to the 1/3 power, if you will. So then, no. What are you, like 0 for 7 today? All right, let me, okay, so John just said you must distribute your power.
That's not what I said. It's a cubit.
Did you say qubit? Oh, qubit. I heard distribute. Okay. Thank God. Okay. Good. 5,000 points for you. Good job. Okay. Yeah. Good. I thought you. Okay. Never mind. I won't go into what I thought you meant. So okay. So qubit, not distribute, but qubit. Yeah. To get rid of the 1/3, we are going to raise it to a power of 3. So we're going to power up by 3 on both sides. 1/3 times 3 is 1. So we're left with 7x plus 6 equals negative 2 times negative 2 times negative 2 is? There we go. And then subtract 6 So 7x equals negative 14, and then x equals negative 2. And then we are going to check our answer. But I'll give you a little hint. Cubic functions always work.
Okay.
Cubic function
I don't even know how to do a cubic function.
on your calculator? Well, you could do to the 1/3 power, actually.
Smart.
So if you're not sure how to do the cubic on your calculator, it's under the math menu for you TI folks. But you could do to the 1/3 power using the little caret feature, the little caret character thingy. All right. So as long as your 1/3 is in parentheses, then that'll work. I have a cubic on the Casio, I think. Yeah.
Oh yeah, there's cubic.
Yeah. Oh, I do have a cubic. Never mind. It is right there. There's the cube root. Cube root of 7x plus 6 and negative 2. Yeah, so the cube root, this is my breaking wave function. I like to pretend I'm boogie boarding. Or body surfing, that's fine too. And you can see, where do they intersect? Looks about like negative 2, doesn't it? Yeah. Okay, so you can see that. That's pretty good. A cubic is always going to work. It's even things that really screw everything up. The cube root is under the math menu. How do you know? You use it for the past 25 years. And you learn in your math class when you use your calculator. All right. Okay, you're figuring stuff out. Pretty nice, right? Okay. All right, this one different. You'll notice on the first 3 that we had, our radical was isolated, and that's a good strategy. So we really would like to isolate the radical. I'm going to say this term itself is probably okay. I want to isolate this term so that I can square it more easily. Okay. Right now, let's pretend I had 2 equals x minus 3. Okay. If I had to square both sides like this, what do I have to do with the x minus 3 quantity squared? It's x minus 3 times x minus 3, isn't it? And then I have to FOIL and get x squared minus 6x plus 9 equals 4. Like, that becomes challenging, right? Because of that addition or subtraction. Addition and subtraction just messes everything up, okay? So I don't want to square something around an addition or subtraction because it makes it really, really hard. It's this scenario, all right, which we will do, by the way. So what I want to do is I want to isolate this thing. So I'm going to go ahead and subtract 3 to the other side. You will have one in your homework, like this. All right, equals 2 radical x. You could divide off the 2 if you wanted to, but it's not necessary because this is pretty easy to square. So we are going to square both sides. And let's think about what this means for a second. On the left-hand side, this means x minus 3 times x minus 3, correct? Okay, and what do you have to do over here? Multiply it all together, right? Distribute it together? Okay. All right, so that's fine. On this side, this means 2 times, can I just write x to the 1/2? Okay. Times 2 times x to the 1/2. Is that the same thing?
No.
I'm writing 2 of them, right?
Yes.
Oh, okay. All right. So we're just multiplying. It's just a product. That's right. No pluses and minuses. It's so much easier, this one. Okay. All right. So let's look. On the left-hand side, we're going to do some super distribution here. What do we get when we distribute? X squared minus 6x plus 9. Good. Over here, there is no distributing. We're just multiplying. All right, so 2 times 2 is 4. X to the 1/2 times x to the 1/2. X to the 1/2. They have the same base. What do you do with the exponents? Add the exponents. What's a half plus a half? 1 whole. All right. Okay. So really, you guys clearly need a break. Okay. All right. This is a quadratic equation. How do we solve?
Quadratic.
Set it equal to 0. And so we have x squared minus 10x plus 9. And then what should we do? Factor double bubble. You could use the quadratic formula, but the factoring is faster. X times x is x squared. What times what is positive 9? Negative 9 and negative 1. So that means x equals 9 or x equals 1. Okay, now the question is, which one?
It's obviously
Is it obviously?
well, yeah, because 2 times anything is greater than 1, other than 0 and half. And there's a plus.
Oh, that's some interesting logic, sir. All right. Oops. Okay. So again, I am going to check this in my calculator. You could just plug the numbers back in. So you could plug in the 9. All right. So 2 times the square root of 9. 2 times 3 plus 3 is 9. So that does work. And if you did 1, 2 times the square root of 1 is just 2. Plus 3 is 5. Does 5 equal 1? No. All right. So, but again, you could graph this. I'm going to put the left-hand side in y1 and the right-hand side in y2. So I have an x, and I have 2 square root of x. Oh, I guess I'll put that in parentheses just for giggles. Plus 3. And if I draw that, there's the solution where x is 9. Okay? 1 is a false solution. 9 is the only solution. Okay? So you can plug it in and check. This is x to the first power, which means at most there is one answer. Since we got 2, we know one of them is false. X to the third means there's 3 answers. X squared means there's 2 answers. At most.
And it's 3 answers that would always work. Like if you like because we got 2.
Yeah.
Only.
I'm adding x.
All right, ladies and gentlemen, have fun with that. Oh, I have another one. I don't.
No, just one.
But it's already 28 minutes. It's only been 28 minutes. You guys saw that.
Well, no. So I do need to do this one. This is the hard one. So I did this one because I wanted to remind you, and I did it at the beginning, so this was really not necessary. I wrote powers of 1/2, didn't I? But what does that really mean? Square roots. Okay. So what do you want to use? You want to use the 1/2 or do you want to use the roots?
Roots.
Okay. So we can do that. So I'll just write it using roots. So we have x plus 25 equals the square root of x minus 2. Really glad my pens are erasable. And then plus 3 on the outside. I told you before, when you have radicals, you need to isolate the radical. Well, the problem here is we've got multiple radicals, so we can't really isolate, okay? And so this turns out to be the easiest thing to do, separate them. Okay?
Abolish that.
Well, I mean, I could move the 3 over here, but I would still... So I do have to square both sides, just like we were doing. So we're going to square both sides, and this gets very tricky. Okay. So first of all, what is